What are the differences between mass and weight? Let's discuss about this. There are some basic differences I want to mention here. What are these basic differences? Mass. Number one, quantity of matter contained in the body is mass of that body. I mentioned previously that quantity of matter contained in this small piece of paper is certainly less than quantity of matter contained in this big piece of matter. Maybe here 1 million molecule, maybe here 100 million molecule. That's why quantity of matter contained in a body is the mass of that body. But what is weight? The force with which Earth attracts a body towards its center is the weight of that body. It means with what force Earth is attracting this piece of paper towards its center is the weight of this piece of paper. And with what force Earth is attracting this another small piece of paper towards its center, this is the weight of a small piece of paper. Now let's talk about the second one. It is measured by using a beam balance. Previously I mentioned this. Look at this diagram. In this diagram, mass is measured. Just now I told it is measured by using beam balance. This is beam balance. In beam balance, a standard mass is taken in one of the pan, and unknown mass is taken in another pan. And when beam becomes balanced, then this standard mass is said to be equivalent with this unknown mass. But one of the interesting matter I want to mention here, actually while measuring the mass, we are comparing the gravitational force of the Earth acting on this standard mass with the gravitational force of the Earth acting on the unknown mass. With how much gravitational force Earth is attracting this standard mass towards its center, when becomes equal to the gravitational force acting on this unknown mass towards the center, then we can say that these two masses are equal. That's why mass is measured by comparing gravitational force of the Earth acting on standard mass with gravitational force of Earth acting on the unknown mass. It means mass of a body cannot be measured in space. There is no any gravitational force at all. Okay, we'll talk this later. Now let's go to the second point again. I told you just now it is measured by using beam balance, mass. But weight, it is measured by using spring balance. Look at this. This is a spring balance. It measures the weight of the body. Weight of the body means the force with which Earth attracts a body towards its center, and this spring balance is suspending the same by applying the same force with which Earth is attracting it towards its center in the vertically upward direction, and this is reaction force. In terms of reaction force, this spring balance measures the weight of the body. Now let's come back to third point. Its SI unit is kilogram. Its SI unit is Newton. There are other units also. We are focusing on SI unit only. Number 4, it is a scalar quantity. Which one? Mass. Why scalar quantity? If someone says that mass of a body is 10 kilogram, then what it means? It means this 10 kilogram is the magnitude of the mass. But mass is quantity of matter. How can we say that this much quantity of paper has particular direction? We cannot expect the direction of quantity of matter. That's why it has no any direction, so it is scalar quantity. It has only magnitude. But weight is vector quantity. Why I am saying it is vector quantity? If someone says that weight of this body is 10 Newton, it means this 10 Newton is magnitude of weight, and as we know that this is force and its direction is towards the center of the Earth, that's why it has both the magnitude and direction. It is a vector quantity. Now fifth one, its value remains same at any place of the Earth. Which one? Mass. What it means? If this piece of paper has 100 million molecules, if it is taken to North Pole, it remains same, 100 million molecules. If it is taken to equator, remains same. Its molecule never changes. It means quantity of matter contained in this body remains same whether it is taken inside the Earth or at North Pole or at South Pole, whatever we do, but its mass remains same, quantity of matter remains same. But look at the weight. Its value varies from place to place of the earth. When it is taken to the pole, its weight will be more. And if it is taken to the equator, its weight will be a little less. This we'll discuss in other classes later, but value of weight varies from place to place of the earth. Mass remains same. These are the basic differences between mass and weight.